Okay, welcome to our video on StyleGAN latent space control with conditional GANs. So StyleGAN is a state-of-the-art network for generating realistically looking faces. And basically these images are generated from random Latin codes that you can sample. But in our case, we want to control the output of these images. So we want to specify some desired shape and appearance, basically by training an encoder network where we can provide some source image and some target landmarks. And the output should be the latent embedding, such that when it's fed through StyleGAN again, we get the manipulated image, so the source image with the target landmarks. And the motivation behind that is that image manipulation has quite a large number of possible applications, going like from movies and games to even privacy applications. And also we want to make this very easy and accessible by providing these landmark sketches. And also, as mentioned, since StyleGAN is a state-of-the-art network, we want to investigate how well we can use a pre-trained model for that. So regarding the architecture, again, here's the encoder we want to train that gets the output constraints and then returns here the manipulated image. And in order to make sure that this image has the target landmarks that are desired, we basically train a conditional discriminator where we feed in these pairs of the manipulated image and the target landmark. And then it basically assesses how realistic this pair is. So it's also there for making the outputs very realistic and the overall quality better. But also, we must make sure that the appearance of the person stays the same. And for that, we basically apply cycle consistency. So what we're doing is that we take the manipulated output image and we feed it again in the encoder. But now we actually provide the landmark that we started with, so the original landmark of this image. And then the output of the StyleGAN should ideally be very close to the original image that we started with, so that we can take the reconstruction loss. Okay, now let's dive a little bit deeper into the encoder part. So here's basically a detailed view. And since the task is quite difficult because we have to do both the embedding and the manipulation, we decided to split the task by first using some pre-trained embedding network, which gives us the latent representation of the image. And then here's basically our autoencoder where we feed in this latent code and also our target image. And then what we get out is some difference vector, which basically represents the shift in the latent space that we need, and which is then just added to the latent code we started with. And then the manipulated latent code that we get out here belongs to the final manipulated image.
So for our dataset, we're using the Flickr Faces high quality dataset. And due to computational constraints, we're using the downsampled versions of 128 by 128 pixels. The landmark images were created from the same dataset by extracting face key points and then drawing these sketch images you see below from them. Also, since the official implementation of StyleGAN and the corresponding embedding network we're using only provide pre-trained models for higher resolutions, we had to train both of these from scratch at the beginning of the project. Now let's take a quick look at some of the results. Here you can see a set of landmark images being applied to different input portraits. The overall appearance of a person is well preserved, and the desired shape is reasonably well applied. More results can be discussed in the Q&A session. Lastly, let's take a look at some quantitative evaluation. To our knowledge, there are no existing methods for the task of conditioning StyleGAN output with face landmark images. That's why we're focusing on an ablation study to evaluate the impact of our architectural choices instead. We employ 3 types of metrics for our study. First, an FID score to measure the realism of our generated images, then a Hausdorff distance between the target landmarks and the extracted landmarks from the output to see how accurately the shape has been applied. And lastly, cosine similarity between the appearance input and the generated images to measure the closeness in appearance. Here you can see the results of said ablation study. At the bottom row is our full architecture that we presented today. It shows a quite acceptable FID score that even exceeds the score for the pure embeddings we use in our approach. As for the other metrics, it lags slightly behind in case of the landmark adoption. However, since it heavily outperforms all the other iterations in terms of appearance similarity, this is a worthwhile trade-off. To conclude, we have shown that the use of a conditional discriminator works well for StyleGAN latent space manipulation based on appearance and shape constraints. Hereby, the results heavily depend on the quality of the pre-trained StyleGAN and embedding network. So we expect the results to further improve in quality when using more fine-tuned models like the officially provided ones, for example. Thank you for watching, and see you on Friday.